Hey everybody, and welcome back to another Mad Mufasa math movie. This is the only place where you get to be the psychiatrist and solve all of today's math problems. Today we're going to be covering 1.6 two-dimensional figures on page 56 in your book. So get your stuff ready and let's get to learning. We are going to start off with vocabulary because I know that is the only reason why you tune in day after day to see these videos. It's not because you have to. It's not because it's for homework. It is because you love vocabulary. So I would be so upset if I let you down. So we are going to do a bunch of vocabulary today, and you are going to be happy, happy, happy. All right. Our first vocabulary word that we're talking about today is the word polygon. And a polygon is just a closed figure formed by a finite number of coplanar segments called sides, so that, and there's a couple of stipulations. One, the sides that have a common endpoint, they are not collinear. In other words, they cannot be a straight line. They must form an angle with their endpoint. Stipulation number two, each side intersects exactly two other sides, but only at their endpoints, meaning that you cannot have two lines intersecting each other somewhere in the middle of that line. It has to be at their endpoints. If it's not at their endpoints, then it's not a polygon. If you want some examples of things that are polygons and things that are not polygons, check out the graph, check out the picture on page 56 in your books, and it will give you some that are and some that are not. We do not include curved or rounded figures in polygons either. The vertex of the polygon is where the two line segments meet up. So for example, if you were to have a triangle, then you have three vertexes. Here's one vertex, two vertex, three vertex. Each one of those is a vertex of this polygon, and we call them vertices. So if we were going to name this triangle, we would name this triangle by its vertices, and this would be triangle ABC. If you have a square, you would name it ABCD, a pentagon ABCDE, and so on and so forth. Two more words are concave and convex. And these are ways that you can classify different polygons. And this is how you can test to see whether or not a polygon is concave or convex. I call it the line test. If you were to take each line, so in this case the triangle, and if you were to extend those lines outwards. So you extend this line out here, this line out here, this line going here, this line going here, and here, and out here. You can see that none of those lines go through the middle or the inside of the polygon. If that's the case, then this is a convex polygon. On the other side, if we look at this one over here, if we were to do the same test, we were to extend this line in both directions, extend this line in both directions, and then we're going to extend this line in both directions, and this line in both directions. You can see that what we have is that when we extend those lines, it goes through the middle of the polygon. When that happens, like it does right here, we call that a concave polygon. So this is a concave polygon. If you're not sure which one is which, just run the line test and it'll help you figure it out. Moving on, the next word is an n-gon, which is a polygon with n number of sides. And we start that at 13. Because if a polygon has 3 sides, we call it a triangle. If it has 4 sides, a quadrilateral. 5 sides, a pentagon. All the way up, we have something all the way up until 12, which is a dodecagon. But starting from 13 on, if it has 13 sides, we just call it a 13gon. Or if it's 15 sides, we call it a 15gon. All right? Equilateral polygon is where the polygon, all of the sides are the same length. They're all congruent. An equal angular polygon, the polygon has all angles that are congruent. All the angles measure the same. And if you have a regular polygon, you know that it is a convex polygon and that it is both equilateral and it is equal angular. If it is an irregular polygon, you know that it's not regular. Shocker. Yes, collect your breath. Moving on to the perimeter. You've done this for a long time now. The perimeter is the sum of the lengths of the sides of the polygon. So we're just talking around the outside of the polygon. The circumference is the distance around just a circle. And in the area, we're talking about the inside of a polygon and how many square units it takes to cover the inside of a polygon. Here you have a nice fancy perimeter, circumference, and area table that gives you all the formulas that you'll need for this lesson. If I was a good student like yourself, would write these down in my notebook so that way I could have them. The perimeter for a triangle is B plus C plus D. The area is 1/2 the base times the height. Perimeter is S plus S plus S plus S, or 4 times S. And in the area is just the side squared. The perimeter, I'm not going to go through all these. I'm done. You can read this. You don't need me to read it to you. But I would pause this here, and if you haven't got this written down yet, write down each of these so that you can have it for reference later on. If you're not sure what a letter means, this little thing right here tells you what C, L, A, R, D all stand for. Now, the second reason I know you love to watch these videos is because I know you love doing the examples. So I wouldn't want to let you down, so we are going to do some examples. Is that some screaming of joy I hear in the background? Of course it is. That's the enthusiasm I'm looking for. This is example number 2. This says find the perimeter or the circumference and area of each figure. So we are looking to find the area and the perimeter. Not one, not the other, but both of them. So we look at our formulas, if you need to look at your formulas. And I know that this is a rectangle, so this has to be 2.1 and this has to be 3.2. So if you look at your formulas, you can either add these all together or you can do 2 times L plus 2 times W. Doesn't matter, it's going to get you the same thing, either way you look at it. So 3.2, 2.1, 2.1, this is the perimeter. 2 plus 2 is 4, plus 1 is 5, plus 1 is 6. Bring down your decimal. 3 plus 3 is 6, plus 2 is 8, plus 2 is 10. And I did not put the units on here. This is centimeters. So the perimeter is going to be 10.6 centimeters. Now to find the area, we're going to do length times width. So we're going to do 3.2 times 2.1. And let's see, 2 times 1 is 2. 3 times 1 is 3. Put your 0 as your placeholder. 2 times 2 gives me 4. 3 times 2 gives me 6. Draw your line, add them. And then we have 2 decimal places in our problem, so we need to move our decimal point 2 times. And we have 6.72. centimeters squared is our area. Just like that. Here we have a circle, and just like the last problem, we need to find the circumference and we need to find the area. So what we're going to do is to find the circumference, the formula is pi times the diameter, or it's 2 pi times r. We don't have the diameter, we have the radius, but if we wanted the diameter, we just know that it's double the radius, and double the radius in this particular problem is going to be 6, so our diameter is 6. So now I can use pi times our diameter, which is 6 times pi, and that's going to give us around a circumference. When you do 6 times 3.14, it's going to give you something around 18.85 inches. For area, our formula is pi r squared. So here we do need our radius, and it's going to be a equals pi times 3 squared. 3 squared is 9, and so I'm get pi times 9. And when you do pi times 9, or 9 times 3.14, you get roughly 28.3 inches squared. We're getting pretty good at this, aren't we? Make sure that you read your instructions, that you're not too much in a hurry, that you forget to do one or the other. Alright, this one is your OYO. This one you're going to find on your own both the perimeter and you're going to find the area. So pause this video here, please, and find these two things. Alright, for your perimeter, you would go and you would add up all your sides, or you could do 6 times 2 and 5.5 times 2 for your perimeter. And for this problem, your perimeter should be 23 feet. For your area, length times your width, you should get 33 feet squared. It is important that you put your units on there. So in this case, we're dealing with feet. So make sure you put your feet. And if you're doing area, make sure you put your unit and that it's squared. Here's another OYO on your own. So if you could please pause the video once again and find the circumference and the area for this circle that has a diameter of 6.2 centimeters. Okay, if you did that for your circumference, using your formula either 2 pi r or the diameter times pi, you should get somewhere around 19.5 centimeters for your circumference. For your area, you should get 30.2. Don't forget your units and that it's squared. Here's a standardized test practice example for you. I know you love these. Yolanda. She has 26 centimeters of cording to frame a photograph in her scrapbook. Which of these shapes would most or all of the cording and enclose the largest area? I think I forgot to type the word use in there. It needs to be use the most or all of the cording and enclose the largest area. And then you have 4 different options. Option 1 is a right triangle with each leg about 7 centimeters long. Option 2 is a circle with a radius of about 4 centimeters. Option 3 is a rectangle with a length of 8 and the width of 4.5 centimeters. And option number 4 is a square with a side length of 6 centimeters. What this is asking us real quick is which of these 4 options that I just read would use most or all of the chording that she has. In other words, would have the largest perimeter and enclose the largest area. So we're looking for which one of these shapes has the largest perimeter and also has the largest area. The only way that we're going to be able to answer this question is to go through and find the perimeter and the area for each of these 4 different options. So this is kind of like a buy 4, get 1 free type thing. You get 4 problems all in one. There's no use complaining about it, so we're going to start with the right triangle with each leg about 7 centimeters. And the thing that we need to know about a right triangle is that if each leg is 7, we have to find what the third leg is, this longest. This isn't the leg, I'm sorry. These are the legs. We have to find out what the hypotenuse is. And if you can remember back to how to find the hypotenuse, it's going to be a squared plus b squared equals c squared. So this is going to be c. Now let's change up 7 squared plus 7 squared equals c squared. Then we get 49 plus 49 equals c squared. And then when we do 49 plus 49, we get 98 equals c squared. And then we're going to take the square root of 98 because we have c squared over here, so we need to take the square root. And the square root of 98 is somewhere about 9.9. So c, this side over here that we've labeled c, we can change that and we can make that 9.9. Now that we've done all that work, and we've worked so hard to find out what the hypotenuse is, that allows us to figure out just our perimeter. So to find our perimeter, let's add up all the side lengths. Our side lengths is, one of them is 7. The other one is 7. I don't know why I can't erase this. Right? So that's 14. And then we add 9.9 to that. And so the perimeter of just this triangle is going to be, let's see, 14 plus 9.9, 23.9? 23.9 centimeters is our perimeter. Now, that's our perimeter. Don't forget we have to find the area. And the area is 1/2 the base times the height. So that's 1/2 the base, which is 7, times the height, which is also 7. Don't use the 9.9, that's a hypotenuse. The height is how high the triangle is. So we're going to do 7 times 7, and then we're going to divide that by 2 or multiply that by 1/2. And when we do that, we get, what do we get? I lost my spot. We get 24.5, there it is, 24.5 centimeters squared. And that's the area of just this triangle. We have to determine whether or not, though, that it uses the most chording and that it has the biggest area. So we're not done yet. Our second option that we're going to be dealing with is a sucker with a radius of about 4 centimeters. So there's my nice little picture there. I'm such a great artist. I'll sell it on eBay and make pennies. All right, we need to find our circumference of this circle. So to find the circumference, we're going to do 2 times pi times r. So circumference equals 2 pi r. In this case, r is 4. So 2 times 4 is going to be 8, and then we're going to have 8 pi. And when we do 8 times pi, we're going to get something about 25.1. All right. To find the area, it's going to be pi r squared. And instead of r, we're going to put in 4. And then we're going to get pi times 16 because 4 squared is 16, and 16 times pi gives me an answer of about 50.3 centimeters squared. So here we have the circumference and the area of our second figure, the circle. Our third figure is we have a rectangle, and in the rectangle, our length is 8 centimeters, and our width is 4.5. To find the perimeter, we can do 2 times the length, which would be 16, and 2 times the width, which would be 9. And that would give us 16 plus 9 is going to be 25 centimeters. To do the area, we would need to multiply those two together, length times width. So 4.5 times 8. 8 times 5 is 40. 8 times 4 is 32, plus 4 is 36. And I don't need that 0 because the decimal goes there, so the area is going to be just 36 centimeters squared. It goes fast once we get the hang of it, right? And our very last shape. We have a square with a side length of 6. Now, hopefully, I don't have to say this, but I'm going to say it anyway. We need to find the perimeter, and we need to find the area, but we only have one number. What are we going to do? Well, you should know from back in kindergarten that a square has all the sides that are the same. So if this side is 6, then so is this side, and this side. And so our perimeter is 6 plus 6 plus 6 plus 6, or 6 times 4, and we get 24. The area is just 6 times 6, since this side is 6 too, or 6 squared, and that's 36 centimeters squared. Wow. And then we're all done. But now the last part is just to determine which one of these has used the most chord, the largest perimeter, and also has the biggest area. Here, I'm keeping track of everything that we just found. The right triangle with the perimeter of 23.9, the area of 24.5, the circle with a circumference of 25.1, the area with 50.3, the rectangle with the area of the perimeter of 25, the area of 36, and the square that had a perimeter of 24 and the area of 36. Looking back at the question, they asked us which one would use the most chording and have the largest area. So there's really only one answer that sticks out, and that obviously is the circle. The circle would use the most chording to go around the circumference of the circle. 25.1, just barely beating out the rectangle, which would use 25. But look at the area. The area of the circle is what really makes it win, okay? Because the area has a 50.3, and the next closest is the square and the rectangle with 36. So our answer, congratulations, you deserve the trophy, is the circle with a circumference of 25.1 and the area of 50.3. Now you get to do the same thing. Dasan has 32 feet of fencing to fence in a play area for his dog. Which shape of the play area uses most or all of the fencing and encloses the largest area? You get to do the exact same thing we just did with these 4 shapes. Find the area, find the perimeter of each of them, and then choose the one that is the biggest. Unpause the video when you're ready to find out. All right. Now that you've done all that work to figure out, or hopefully you have done it, the correct answer is answer number 1. The circle with the radius of 5 feet should come up with the largest circumference and the largest area. Alright, now I know how much you love doing examples and doing math, but all good things must come to an end. So this is going to be our last example. This is example number 4 on page 60. And we're going to have to pull out our good old trusted friend, the distance formula, in order to solve this one. They want us to find the perimeter and the area of this triangle with the vertices P, Q, and R. In order to do that, we're going to have to find the length of each side. That means we're going to have to find the length of side PQ. And then I write an R. With this PQ, we have to find the length of P to R. And then we have to find the length from Q to R. You can save the easy one for first or the easy one from last. And the easiest one is the one that's on the straight horizontal line. These two are going to be more difficult. So to find the length of this guy here, all we have to do is count it since it's on a horizontal line. 1, 2, 3, 4, 5, 6, 7. So the distance of QR is 7. Write that down so we don't forget it. There we go. Now the second part is where it becomes a little bit more interesting. Let's find PQ first. So we're going to be looking from P to Q, and we have to use our distance formula to find out how far is in between those 2 points. So remember, it's going to be the square root, and then we have x2 minus x1. Let's do negative 1, and then let's do minus a negative 3. Remember, that's going to be squared. Add that to our y2, which is going to be 3, minus our y1, which is going to be negative 1, and square that. Now, we're just going to solve what's underneath the radical. Negative 1 plus 3 is going to be 2, so that's going to be 2 squared. 3 plus 1 is going to be 4 squared. 2 squared is going to be 4 plus 16. And the square root of all that, so the square root then of 20. And the square root of 20 is something around 4.5. So really what we're looking at is that Q to P, there we go, is 4.5. And write that down so we don't forget. Now the next thing we have to do is find P to R. And we're going to use the same thing again. We're going to do the distance formula. And then we're going to have to do x2 minus x1. So we'll do negative 1 minus x2. Square that. We're going to add that. Then y2, that we'll use 3. And we have to do minus y1, which is a negative 1. And square that. Now let's figure out what we have. Negative 1 minus 4 is a negative 5 squared. Plus, let's see, 3 plus 1 is going to be 4 squared. Then we have 25 plus 16. That's under the square root. 25 plus 16 is going to be the square root of 41. And the square root of 41 is somewhere around 6.4. So I'm going to write that up here. Now we have all the information that we need to actually answer the question that was asked of us in the beginning. So when we were in the beginning, we were asked for the perimeter and we were asked for the area of this. So for the perimeter, easy. All we have to do is add these up. 7 plus 6.4 plus 4.5. We get 9. Bring down your decimal, and that's 17.9 square units. For our area, we need to do 1/2 the base times the height. And we already know our base. Our base is the bottom part. That's right here. That's going to be 7. And our height, we're going to count from here. We're going to go to the tallest point that we have is 1, 2, 3, 4 units. So our area is going to equal 1/2 the base, which was 7, times the height, which is times the height, which was 4, and then we get 28 times 1/2, or our area of this triangle is going to be 14 square units. Alright guys, well that's going to bring us to the end of today's video. You made it through it. Way to go. Glad you guys did it. I knew you had it in you. Today, I'll leave you with a joke. That joke is, why did the dime not roll down the hill after the nickel? Because the dime had more sense. Guys, I'm so glad that you were able to tune in today. I hope it made sense. Hope it got it through to you. I want to thank Mr. Bruno Mars for writing the music for our video today. I know that's what he was meaning to do. But anyway, thank you so much for paying attention, and hopefully you got something. We'll talk to you next time. And remember that God loves you.